Today, we are delving into the concept of virtual memory. Imagine you are trying to organize a small desk but need space for all your books, notes, and gadgets. What if you had access to a magical storage room next door where you could shuffle in and out the things you need at the moment? This concept is not just a dream, it's how computers handle memory challenges through virtual memory, an elegant trick to make your machine seem smarter and faster than it is. Idea of virtual memory. Think of your computer's RAM as the desk where the work happens. It's fast but limited in size. When you run out of disk space, what happens? Virtual memory steps in like a nearby storage room, extending your disk using part of the hard disk or SSD as temporary storage. When your RAM fills up, the operating system temporarily moves less used data to a reserved part of your hard drive called swap space or page file. This illusion makes the computer think it has more RAM than it physically does, enabling multitasking and large applications to coexist. Pages and page tables. The secret source of virtual memory lies in pages and page tables. Pages. Data is divided into small uniform chunks, example 4 KB each. Both RAM and swap space are divided into these manageable chunks. Page table. A magical map that translates a program's virtual address, that is where it thinks data, is to the physical address, that is where data actually resides, RAM or disk. Page faults. What happens when your program tries to access a page that's not in RAM? Page fault. It's not an error. It's a cue for the operating system to fetch that page from disk into RAM. The program pauses briefly, just as you might pause to grab a book from another room. Once the data is in RAM, the program resumes smoothly. Smart paging algorithms like least recently used LRU decide which pages to swap out of RAM, just like you decide which books to return to the shelf when your desk gets cluttered. Why virtual memory is game changer? Virtual memory is not just a convenience, it's a revolution. Multi-programming. Seamlessly run multiple applications without worrying about limited RAM. Isolation and security. Each program operates in its own bubble, preventing one program from accidentally overwriting another's data. Developer convenience. Programmers can code as if there is a huge chunk of memory available, leaving the operating system to handle the tricky details. Demand paging versus swapping. A tale of two techniques. Demand paging. Data is loaded into memory only when needed, ensuring RAM is used efficiently. Swapping. Entire program or processes are moved between RAM and disk. While less common today, it paved the way for modern memory management techniques. Performance matters. While virtual memory works wonders, it's not perfect. The problem. Accessing disk is much slower than accessing RAM. Thrashing. When the system spends too much time swapping pages in and out of RAM instead of running programs, performance tanks. But modern systems use SSDs to reduce delays and advanced algorithms to optimize page faults, keeping the experience smooth. Virtual memory in action. Let's see where virtual memory shines. Hibernation. Saving your entire system to disk so you can pick up where you left off. Virtual machines. Allowing memory for guest operating systems efficiently. Multitasking. Switching between applications without breaking a sweat. The future of virtual memory. With SSDs becoming faster, the performance gap between RAM and storage is shrinking. Emerging non-volatile memory techniques may blur the line between RAM and disk, creating even faster and more efficient systems. Interesting fact is, in the future, we might not even distinguish between RAM and disk. Memory will just be. By concluding, virtual memory is the unsung hero of modern computing. By creating an illusion of limitless memory, it has transformed how we interact with computers, enabling multitasking, security, and convenience. It would be very frustrating to close one program every time you opened another. Virtual memory eliminates this limitation, creating the seamless experience we enjoy today. Virtual memory proves that clever engineering can turn limitations into strengths. It's more than a technical term. It's a core concept that shapes the way we use technology every day.